Let's complete the definition of the mathematical model. If I go back to a PowerPoint slide from earlier that shows the governing equations and boundary conditions, we can see, the entire mathematical model, and ANSYS knows that that's the governing equation we want to solve because we have dragged steady state thermal, and we have set the analysis type to 2D under geometry. So that's turned on, and it's using K for structural steel by default, but K doesn't matter in the governing equation. So I'll leave K alone for now. And we have the domain, and the only thing we need to specify are the boundary conditions. Let's start with the bottom boundary condition, the isothermal boundary condition. So I'll go into mechanical. I'll do some tidying up. I will say zoom to fit, and I will say select geometry and make sure the project is saved. Okay, and then highlight steady state thermal, and it gives you the boundary conditions that you can specify, and select temperature. And it needs to be set to 1 degree Celsius, and I need to set it on a line, so select the edge selection filter here, select the line and say apply, and set it to 1 degree Celsius. These two are insulated boundaries, so there can be no heat transfer perpendicular to the boundary, and that's a default. So I don't need to go in and do anything at those boundaries. I mean, I could go and say perfectly insulated, but that's a default, so I don't need to do anything there. And at the right boundary, I have a convection boundary condition, so I can select the boundary and then select the boundary condition or vice versa. So I'll select the boundary and select convection. The film coefficient is H, which is set equal to BI, and BI is the BO number is 5 in our case. And make sure that the units are metric. Okay, in metric you have 5, and then ambient temperature is T infinity that we need to set to 0 to match our non-dimensional boundary value problem. So that's 0. And then in this boundary condition, there's also another constant appearing, K, and K matters here. It doesn't matter in the governing equations, but it matters here. So let's give it K, and K it gets, from here. So if I go to geometry and highlight surface body, it says the material assignment is steel. So it's going to use the value of steel for K, which is not right. So let's go and specify a new material. So I'll go to the project page and double click on engineering data. Okay, that opens a new tab, and click here and say add a new material. I can give it whatever name. I'll call it Go Big Red for Big Red Cornell, and enter. And I want to give it an isotropic thermal conductivity. That is, the thermal conductivity is the same in all directions. And and then I can specify K, which is 1 in SI units. And you've got to be careful about units, and again make sure that it's set to metric. And then I can go back to the project page, and it says, hey, I get this symbol here. It says something upstream has changed. So I'll right click and say refresh, and that'll bring in the new material property here, and I'll do that over here too. So now it's brought in the new material property, and if I go to mechanical now, and under assignment I'll get Go Big Red. So I'll pick that. And if I bring back the PowerPoint, now it has the right value of K. And I will save the project. Okay, so at this point, the governing equation is defined, the domain is defined, and the boundary conditions are defined. And we can get the ANSYS solver to generate the algebraic equations and solve the mathematical model numerically. That's what we will do next.